I was sitting in a crowded co-working lounge the other day, watching a woman, let's call her Sarah Power, through what looked like her 10th video call of the afternoon. There was no slumped posture, no rubbing of the temples, and none of that glazed, thousand-yard stare we all came to recognize as the universal symptom of a dying spirit back in 2021. When she finally closed her laptop, she didn't collapse. She just picked up her coffee and started a casual conversation, looking as fresh as if she'd just finished a morning walk. It was a jarring sight if you remember the headlines from a few years ago. Back then, Zoom fatigue was treated like an incurable new pathology. We were told by every expert that the human brain simply wasn't wired for 2D interaction, that the lag, the lack of eye contact, and the processing of pixelated faces were draining our cognitive batteries at an unsustainable rate. We thought we were hitting a biological wall, a fundamental limit of the human animal that would eventually force us all back into physical offices just to keep our sanity. But as we sit here in late 2025, something strange has happened. That insurmountable wall seems to have crumbled. According to a landmark report on workplace cognitive psychology released just days ago, the exhaustion we thought was permanent has effectively vanished. The Zoom fatigue that defined an entire era of labor is, for all intents and purposes, dead. What's fascinating isn't just that the tiredness stopped, it's why. It turns out that those few years of screen burnout weren't a sign of a broken system, but the sound of our brains undergoing a massive silent architectural shift. We didn't wait for the technology to get better, we rewired our own biology to handle it. This sudden adaptation, this cognitive restructuring, is perhaps the most dramatic example of human evolution in the digital age. But it raises a deeper, more unsettling question. If we've successfully remapped our brains to live in a virtual world, what parts of our old analog cells did we have to leave behind to make room?
That's a perfect way to frame it. That idea of adaptation leading to these new invisible costs is exactly the tension we need to unpack today.
Right.
Because you see that person, Sarah, and she's just completely fine. She's adept. She's managing these back-to-back virtual calls, and it's almost like a living, breathing piece of evidence for how fast human neuroplasticity really is.
It's incredible.
It is. But the critical point here, the thing we can't forget, is that the initial Zoom fatigue wasn't just collective whining or people being dramatic. It was a real and, more importantly, a measurable neurophysiological disruption.
So it was biological, not just psychological.
Absolutely. It was rooted in how our brains are wired to process information and, crucially, to synchronize with other people. So what we're going to do in this deep dive is trace that entire evolution. We're going to investigate the precise biological failure points that caused that initial fatigue in the first place. Then we'll look at how our brains adapted, how we stabilized those neural processing patterns. And then, and this is the unsettling part, we have to examine the significant structural and psychological things we gave up to get that stability.
What we left behind.
What we left behind. It's a journey, really, from a few milliseconds of lag to the huge macro implications of what it means to live and work with this level of digital autonomy.
Okay, let's do it. Let's unpack this starting at the most fundamental level, the actual physics of human connection. We're calling this section 1, the biology of disruption. And we're really focusing on that thing that was holding us back at the start, that invisible, insidious latency that just haunted the first few years of remote work. And the key concept here, the objective metric that scientists finally landed on to measure if two people were actually, connecting at a biological level. It's called interbrain synchronization, or IBS.
Right, IBS. It sounds incredibly complex, but the core idea is pretty simple. Think of it less like you're just understanding words and more like you're in a duet with someone. Interbrain synchronization is this quantifiable thing that happens where the brain activity of two people talking, so the speaker and the listener, their brain waves literally start to align in time and frequency.
They get on the same wavelength.
Literally. That's not just a metaphor. It's the moment your minds are truly in sync. And when that synchronization is high, communication quality is amazing, attention is shared, the conversation it feels natural, it flows.
So how do you even measure that? I mean, it sounds like science fiction.
Well, it's surprisingly precise. It relies on electroencephalography, EEG, which is where they put those caps with all the sensors on people's heads to measure brainwaves. They collect that data from both people at the same time while they're talking.
And then what? What are they looking for in all that data?
They're looking for something called a phase locking value, or PLV. It's a bit technical, but it basically captures how synchronized the phases of specific brainwaves are between the two people. And for this research, they really zeroed in on 2 specific frequency bands.
Right, which tell you about different states of attention, don't they?
Exactly. First, you have the alpha waves. They're typically in the 8 to 12 hertz range. We usually associate them with being relaxed but awake, but they're also really important for selective attention and for inhibiting distractions.
Okay, so that's the paying attention wave.
In a way, yeah. And then you have the beta waves, which are faster, running from about 12 to 35 hertz. Those are strongly linked to active concentration, when you're really engaged in problem solving or deep mental effort.
So if my alpha and beta waves are locking up with yours while we're talking,
it's a clear biological signal that information transfer between us is smooth, it's efficient, and we're both cognitively engaged in the same task.
And we knew for a while that this synchronization happens even over video chat, right? It wasn't a total dead zone?
No, not a dead zone. It does happen. But, and this is the crucial finding that came out of these long-term studies, the level of that synchronization is significantly reduced. It's attenuated during remote calls compared to the sheer richness of a face-to-face conversation.
And that reduction is all about 2 missing things. The delay, the latency, and then just all the other stuff.
All the other stuff. The reduced sensory richness, you're missing most of the body language, the micro expressions that flash across a face, the simple 3D spatial cues of having another human being in the room with you.
To put a number on it, what's the difference?
Well, face-to-face interactions allow for this incredibly high degree of phase locking value. The sync is so good that it actually reduces the metabolic energy your brain has to spend on the conversation. It's efficient. But the second you put a screen, a microphone, and a camera between 2 people, you're adding all these processing steps. And every single one of those steps imposes a tiny cognitive tax.
And all those taxes add up.
They add up. And that cumulative tax is exactly what manifested as that initial really acute Zoom fatigue that everyone was feeling.
So if latency is the big villain here, what's the exact point where it becomes, truly disruptive? Is there a number?
That takes us to pinpointing the actual latency threshold. And to find it, the researchers had to get really, really specific. They had to build a lab that cut out all the messiness of the real world.
Yeah, the experimental setup here was honestly quite brilliant. They took 22 participants and paired them up into 11 dyads. And they made sure these were people who already knew each other and spoke the same language, so, awkwardness with a stranger wasn't a factor.
Okay, that makes sense.
Then they put these pairs in 2 separate soundproofed rooms about 12 meters apart. All their communication had to go through a controlled digital channel, but the real key, the clever part, was connecting all their equipment with these super long 15-meter USB cables instead of using Wi-Fi or the internet.
So the cables were the control. The cables were the control variable. By hardwiring the whole system, they completely eliminated all the random environmental noise. No unstable internet, no buffering, no packet loss. It meant they could control the exact transmission delay using software, sometimes down to a single millisecond.
So they could just dial in the lag.
They could dial it in precisely. They tested a whole range of delays: 0, 150 milliseconds, 300, 450, and 600. And really importantly, they compared all of those conditions to a true face-to-face control group where the pairs just sat a meter apart.
And the results?
Definitive. This gave us the first objective biological number for the problem. They found a really sharp, nonlinear cutoff point. Transmission delays that go over 450 milliseconds, they just significantly disrupt interbrain synchronization.
Oh.
The neural sync in both the active beta waves and the attentive alpha waves just plummeted. It fell off a cliff the moment that 450 millisecond threshold was crossed.
Let's just pause on that for a second, because that feels like the core discovery of that whole era of neurological fatigue. 450 milliseconds, 0.4 of a second. That is the biological breaking point.
It is.
If the platform you're using puts a delay of 450 milliseconds or more between your brain and the other person's, your ability to truly synchronize, to connect on that deep biological level, is fundamentally broken.
That's the neurological red line. But, and this is important, the counterpoint to that finding offers this huge ray of hope. It's actually the reason we were able to adapt.
Okay.
The remote communication conditions with low delays, so the 0, 150, and 300 millisecond tests, they achieved levels of neural synchrony that were pretty much comparable to face-to-face.
So the screen itself isn't the problem.
The medium is not inherently flawed. It was the timing. It was the specific communication platforms we were all forced to adopt during the peak of the pandemic that consistently pushed us over that biological edge.
And we know from other research, don't we, that the average delay in turn taking on the big video conferencing platforms back then was, what was it, something like 487 milliseconds?
That's the number, 487, which means that just using the standard software put us, on average, 37 milliseconds past the neural breaking point in every single conversation.
That's insane. That tiny 37 millisecond margin.
Yeah.
That's why every conversation just felt subtly wrong all the time.
It does. It wasn't just a feeling. The research also backed this up with specific behavioral consequences of that high latency.
Like what?
Well, they saw a big increase in simultaneous speaking. Both people would start talking at once because neither one could accurately predict when the other person was done. The normal conversational cues were just gone.
Yeah, talking over each other constantly.
And on the flip side, they saw longer periods of mutual silence. People were overcompensating for the lag, waiting too long to speak, which created these really awkward, unnatural gaps in the flow. All those unintended interruptions and weird silences just added more and more friction to an already metabolically taxing process.
Okay, so if the 450 millisecond delay was so clearly wrecking their brainwaves and their conversation flow, did the people in the study actually notice? Did they realize their communication was failing? Which brings us to this idea of the unconscious cognitive load.
And this is where the cost becomes invisible. This is the fascinating part. While their IBS, their brain sync, dropped off a cliff at 450 and 600 milliseconds, only a tiny minority of the participants, I'm talking 8 out of 22 people, consciously reported even noticing the latency.
Wait, really?
Really. The vast majority didn't register the delay as abnormal or disruptive while it was happening. In fact, when they were told about it later, a lot of them just shrugged and said they thought having delays was just, normal for video calls.
So your brainwaves are actively failing to sync up, the conversation is objectively worse, but your conscious mind doesn't even notice the problem. You just feel vaguely exhausted at the end of the day. That's the hidden tax.
That is the hidden tax, and it highlights this critical finding. IBS can be profoundly disturbed, meaning your objective communication quality is in the gutter, even when you are not consciously aware of the delay. Or even if you just think the connection is typical for remote work.
Yeah.
It suggests the real source of the fatigue wasn't the conscious frustration with lag. It was the immense, relentless, subconscious cognitive effort your brain was exerting just to anticipate, predict, and compensate for that 450-plus millisecond gap. That constant internal desk work is what was exhausting us.
That makes so much sense. The brain just hates unpredictability, doesn't it?
Right.
If it's constantly having to run these background calculations to guess if the signal's coming in 300 meters or 600 meters, it's like running a dozen extra apps you didn't know were open.
A perfect analogy.
And over an 8-hour day of back-to-back meetings, that effort adds up to that 1,000-yard stare. The good news, I guess, as we saw with Sarah in the opening, is that our brains did something about it, that neural architecture underwent this massive silent restructuring to normalize the experience.
Yeah. Right. These longitudinal studies show that neuroplasticity just kicked in. It stabilized our neural processing patterns, which allowed us to manage that metabolic energy consumption way better over time. Sarah adapted. She learned how to pay that cognitive tax without going bankrupt.
Yeah.
But here's the thing. That adaptation is only surface deep. While we may have mastered the millisecond gap, while we overcame that biological latency wall, we basically just ran headfirst into a much larger, more structural challenge. The very nature of digital work itself.
Because the exhaustion didn't go away, did it?
Yeah.
Even when the software got better and the latency dropped.
Exactly. The feeling of chronic exhaustion persisted long after those 450 meters issues were mostly solved in newer software. And that suggests the problem just shifted and moved past the physics of lag and into section 2, into the deeper structural costs of living a digital life.
So when we move away from that very technical problem of latency and look at the broader psychological impact of just using information and communication technology, or ICT, all day, we run into this thing that researchers are now calling the digital fatigue paradox.
Yeah.
The core issue seems to be that we all intuitively believe technology makes our lives easier, more efficient. But the reality is often the complete opposite.
The paradox is built on this really fundamental contradiction. Using ICT can, at the exact same time, provide immense utility. It can increase your vigor, your vitality, your productivity, while also increasing your exhaustion and your mental tiredness.
And it's not one or the other, it's both at the same time.
It's both happening in parallel. And what's really insidious is that these beneficial and detrimental effects are often operating within the very same activity. You might finish a big project using a bunch of remote tools and feel feel this huge burst of work vigor, of accomplishment.
Right, you feel great.
But at the very same time, the fact that you did it by working late into the night fueled this massive work-life conflict and a sense of severe overload. The win came with a huge cost.
And crucially, what the research shows is that when you get these mixed results, the bad side, the exhaustion, the fatigue, it tends to be stronger. Much stronger.
It does. The overall statistical trend they found across multiple big studies is really stark. When they found these mixed vigor and fatigue results, the detrimental effects were 4 times more likely to be the dominant psychological factor than the beneficial ones.
4 times. That's a staggering negative bias that's just baked into the structure of digital work.
It is, and it explains so much. It explains why all that early research that only focused on the fatigue dimension, they just asked people, are you tired? It painted such a bleak picture. They were actually capturing the true dominant signal.
They were right. They were just missing part of the story.
They were. Later, more nuanced research started using what's called the bivariate paradigm. They measured both energy and fatigue, and that's what allowed us to see the full picture. People are often invigorated by digital tools. You do feel productive and efficient, but that feeling of vigor is almost always overshadowed by the exhaustion that comes along with it.
Okay, so if the paradox is real, and the negative side is 4 times stronger, let's get into the specifics. Let's dive into the structural mechanisms, the things that have nothing to do with latency, that are driving this exhaustion.
Yay.
The research points to 3 big categories: overload, autonomy, and conflict.
And overload is the big one. It's the overwhelming influence on the fatigue dimension. And it comes in so many different forms. It's not just work overload, like having too many tasks.
Yeah.
It's information overload, interruption overload, and social or communication overload. And the causes are just deeply embedded in the way these digital tools are designed. The ubiquity of the tech, the social pressure to always be online, the complex design features that demand your attention, even just frustrating tech failures. It all adds up to this chronic, pervasive feeling that the work is never, ever done because the input streams are infinite.
I feel this every single day.
Yeah.
The endless Slack threads where you have to scroll back 50 messages just to find the one action item that applies to you.
That's classic information overload.
Or the 200 unread emails in your inbox. Your frontal lobe is getting taxed just trying to filter what's important from what's not. But what about social overload? How is that different?
Social overload is particularly draining in the context of video conferencing. Think about it. In a real physical meeting, when you're not the one speaking, you can kind of relax your face, shift your posture, look down at your notes.
You can disengage a little.
You can. But on a video call, you are performing engagement constantly. You have to monitor your own little video feed to make sure you look right. You have to monitor everyone else's micro reactions on the screen. And you have to consciously project this look of pure attentiveness for the entire meeting.
You're always on stage.
You are always on stage. And that constant performance is a severe source of social and communication overload that just exponentially increases fatigue.
And that expectation of always being on, of ubiquity, that ties directly into the second driver, right? Autonomy. This is the factor that seems to control the vigor part of the paradox.
Precisely. Autonomy is the primary conditional driver for vigor. When employees feel self-determined, when they feel in control of when and how they use their technology, that's when you see positive outcomes.
So things like having flexible telework arrangements, or just having the authority to decline a meeting that really could have been an email?
Yes. Or successfully controlling the boundary between your work life and your personal life. People who have that control report significantly more vigor and way less exhaustion. Vigor is fundamentally tied to a sense of control.
Which means, conversely, if a company puts policies in place that strip away that control, they are actively draining their team's energy.
100%.
Think about things like mandated camera-on policies for every single meeting. Or even worse, that intrusive employee monitoring software that tracks your mouse clicks and your active windows.
Those policies are psychologically devastating. They completely destroy any sense of self-determination. The research is crystal clear on this. That sense of coercion, that perceived lack of control over how you engage, it just demolishes vitality.
It's the difference between choosing to do something and being forced to.
It's everything. For example, if you voluntarily choose to check your email after hours to finish one last task so you can start the next day fresh, that can actually give you a sense of vigor and accomplishment.
Because you are in control.
You are in control, but if your company forces you to check email after hours through aggressive notification policies and an always-on culture, That leads to severe exhaustion and burnout because the failure of control is total.
And that structural loss of control, that constant pressure, that brings us to the third driver, conflict.
Yeah, ICT is just an unparalleled generator of all kinds of conflict. You have technology personal conflict, like your phone buzzing with work notifications during a family dinner. And then the big one, work-life conflict, where the boundary between those two domains just completely collapses. When the technology is designed to be highly interrupting or is overly complex, it generates profound stress. And these conflicts are always mediated by the first two factors we talked about: overload and a lack of autonomy. And they are consistently linked to increased fatigue.
The sources mentioned something called Techno-Invasion.
That's the feeling. The sense that technology is invading your personal space and time. It's a key driver of exhaustion, largely because it forces you into what are called maladaptive coping strategies.
Okay, let's elaborate on that, because I think everyone listening is probably doing some of these right now. What does a maladaptive coping strategy actually look like in practice?
Well, it's essentially any kind of avoidance or short-term relief that ends up creating long-term damage. It can look like procrastination that's disguised as digital activity. For example, doom scrolling through social media for an hour instead of tackling that overwhelming project.
Which just makes the time pressure and work overload worse later.
Exactly. It also looks like constantly staying up late to finish work outside of official hours because your boundaries collapsed earlier in the day. That leads to sleep deprivation and chronic exhaustion. Instead of actually disconnecting to recover, people engage in more digital activity to manage or avoid the conflict, which just deepens the fatigue cycle.
So what does this all mean when you pull the lens back and look at the full complexity of this paradox? If ICT can both energize us and exhaust us, how do we tell the difference between the contexts?
Well, if we connect this back to the bigger picture, the context and the specific type of technology you're using matter immensely. A perfect example is the one we touched on, using conventional ICT, like email or Slack, outside of work hours.
Right.
That single behavior can lead to high work vigor, that feeling of, I'm so dedicated, I'm getting ahead. But at the exact same time, it's fueling higher exhaustion because it intensifies overload and work-life conflict.
It shows that the invigorating process, which is driven by your sense of autonomy and efficacy, and the draining process, driven by overload and boundary failure, they're happening completely in parallel.
Often outside of the traditional 9-to-5 structure, which is why it's so hard to pin down.
This makes me totally rethink the idea of a work break. If I step away from my work on my laptop to check social media on my phone, I'm not actually resting, am I? The studies suggest I'm not.
Absolutely not. The sources are really clear on this. Taking a break by using your cell phone or engaging in any kind of generalized digital distraction actually increases your fatigue compared to a conventional analog break.
Why?
Because the digital break prevents proper detachment. True recuperation requires stepping away from stimulation, from cognitive input. Scrolling through a social feed just shifts the source of the information and interruption overload. It continues the psychological tax, even if it feels voluntary.
And that type of technology is key here too. Can you clarify that distinction between wellness ICTs and conventional ICTs?
Yeah, we see this huge split in the data. The positive beneficial effects, so increased vigor without a crazy jump in exhaustion, were mainly seen with what they call wellness ICTs.
Okay.
These are technologies specifically designed, often using therapeutic or psychological principles, to increase your energy or decrease your fatigue. Think of a science-backed meditation app, or a structured digital fitness tracker, or tools designed for deep focus that block all interruptions.
And the conventional ICTs, they're the bad guys in this story.
They are the majority of the problem space, yes. Conventional ICTs, so your general meeting platforms, corporate email, and especially social networks, were overwhelmingly likely to have negative impacts.
Yeah.
They showed this really strong tendency toward detrimental effects, which, again, were 4 times more likely to be stronger than any benefits they offered.
Because they're designed for engagement, not for well-being.
Exactly. They're designed for maximum engagement, maximum interruption, and minimum cognitive detachment. That makes them fundamentally draining when you're using them continuously.
So let me see if I have this right. We adapted our brains to the technical lag. We got over the 450 millisecond wall. That was section 1. But the chronic exhaustion that's still with us, that's the structural and psychological burden of just relentless, unbounded digital use. It's driven by this constant state of overload and the corporate erosion of our autonomy.
You've got it. We adapted our neural architecture to tolerate the lag, but we completely failed to adapt our social and corporate structures to manage the paradox of using the technology itself.
And that adaptation, that hard-won ability to sit in the box on a screen and function smoothly, it came at a steep price.
A very steep price. And that leads us directly to the final, and I think most concerning cost of all, the loss of our internal cognitive privacy.
We've established that human neuroplasticity is just. It's incredible. We solved the 450 millisecond problem. But the moment we successfully rewire ourselves to handle that high latency, always-on world, we open ourselves up to a whole new kind of vulnerability, an evolutionary vulnerability.
That's right. And that vulnerability is perfectly captured by what's known as the privacy paradox.
I've heard of this. It's the huge gap between what people say about privacy and what they actually do.
It's this pervasive disconnect. We all claim to be highly concerned about our data privacy. We worry about companies misusing our information. And yet, we exhibit extremely low protective behavior. We just click accept on invasive terms and conditions. We share intimate details about our lives. We download every app that promises some small utility.
The numbers on this are genuinely baffling. You see studies where users of huge social platforms will report being extremely concerned about strangers getting their hands on sensitive personal data like their political beliefs or sexual orientation.
Yeah.
And yet, in the same study, nearly half of those exact same people still openly disclose that information right there on the platform. It's like our rational concerns are just being completely overridden by something else.
And the root cause is evolutionary. Our privacy intuitions, our gut feelings about being watched, they evolved in a completely analog environment. They're focused on physical space, on territoriality, and on managing our reputation through visible, contextual social cues.
So ancestrally, privacy was about who was physically close enough to overhear you.
Exactly. Who is physically present, who could see you, and what were the immediate visible consequences of your actions going to be?
If someone was hiding in the bushes watching you, your ancient alarm bells would go off. The environmental cues are there to trigger that protective instinct.
Precisely. But the digital world just bypasses all of those evolved mechanisms. It's characterized by mass, invisible, and permanent data collection. This new environment simply does not have the physical cues, the proximity, the sound, the immediate sense of threat that trigger our primal psychological defenses around privacy.
And the tech companies know this.
They exploit this mismatch. They intentionally remove the friction and the cues that would normally make you hesitate. And instead, they appeal directly to our immediate evolved desires, social connection, instant utility, entertainment. They effectively disarm our primal defenses, leaving our rational concerns with no power.
So we adapted to the latency, but our primal defense system hasn't evolved to recognize invisible, permanent surveillance. And now, the very adaptation we achieved, the ability of someone like Sarah to look perfectly engaged and fresh on a video call, even when she is completely exhausted on the inside, that's now being used against us by the next wave of technology.
You've hit the key point. If you managed to normalize the cognitive tax from Section 1, and you mastered the performance of sustained engagement despite the structural exhaustion from Section 2, you've created an internal cognitive state that you as an individual believe is private. You think your exhaustion is your secret.
But it's not.
But the newest technology, which we're getting into now, is focused entirely on monitoring that precise internal state you're trying so hard to hide.
This is the development of tech that can measure your cognitive state directly, turning your subjective feeling of being tired into an objective, exploitable data stream.
We're talking about highly sophisticated machine learning models. A key example is the Recurrent Video Transformer model, or RVT. This AI was developed for one specific purpose: to monitor real-time mental fatigue in people during demanding cognitive sessions. And it does it just by analyzing subtle, continuous, involuntary facial gestures from a video feed.
And I know the initial studies were on older adults during cognitive training, but the core technology, that's globally applicable. The tech to objectively read your fatigue level from your webcam already exists and is ready to be deployed in a corporate setting.
Absolutely. The RVT model doesn't need a static image of your face. It doesn't need you to fill out a survey where you check a box saying how tired you are. It analyzes the dynamic temporal unfolding of your facial expressions over time.
What does that mean, temporal unfolding?
It means it looks at the change over time. The researchers fed the AI continuous video clips, usually 80-second subclips, and it extracted these dynamic features to generate something they call a gesture-induced fatigue score, or GIFs. The power of this model is that it can capture fatigue signals that are incredibly subtle and completely unintentional.
Okay, but how reliable is it? Did this GIF score from the AI actually correlate with a measurable drop in performance?
It was overwhelmingly validated. The GIF score, the AI's objective reading of your fatigue, was significantly correlated with objective performance metrics, specifically a measurable increase in a person's reaction time during the cognitive tasks.
So when the AI said you were tired, you actually got slower.
You got slower. And this is the crucial finding. The AI measure captured aspects of fatigue that were important for performance over and above what the participants themselves were self-reporting. You might say, no, I feel fine, I'm ready to go, but the GIF score and your slowing reaction time prove otherwise. The AI sees the reality of your cognitive load.
That's honestly terrifying. That the AI could read the reality of the situation better than the person actually experiencing it. So where on the face did this model focus its attention to detect this fatigue, even when people were trying to hide it?
The model showed its highest attention and predictive power when it was analyzing the regions around the eyes and the mouth.
Why there?
Because those are the areas where involuntary muscle fatigue and subtle micro-twitches manifest first. Fatigue leads to slight changes in your blinking patterns, tiny shifts in the muscles around your eyes that indicate a drop in active attention, and reduced muscular tension around your mouth and jaw. These are expressions that are almost impossible to consciously control for a long time.
So even in the real world, where you might be wearing a mask or you're intentionally putting on a neutral, I'm paying attention face, the AI can still find the truth in your eyes.
That's exactly right. The original study noted that even when participants wore masks, which obviously covered the mouth region, the AI could still leverage the nuanced, dynamic unfolding of expressions just from the exposed eye regions to objectively detect mental disengagement.
Wow.
The AI is reading the moment-to-moment reality of your neural state, even if your learned adaptation allows you to mask the subjective feeling of exhaustion. We taught ourselves how to perform presence, and now the machine is looking right through the performance.
We've been so focused on protecting our informational privacy.
Yeah.
Our documents, our passwords, our location data, that we completely missed the emergence of cognitive surveillance, where our actual internal state is being harvested as objective real-time data.
Which brings us to the final cognitive trade-off. Let's connect all the dots. We spent years rewiring our neural architecture to stabilize our energy consumption and get over that 450 millisecond wall. That was section 1. We normalized chronic exhaustion through coping strategies, trying to find some autonomy in a world of structural overload and conflict. That was section 2. But the ultimate irreversible cost of this massive adaptation, this cognitive restructuring, is the total exposure of our internal cognitive state to these invisible monitoring systems.
We achieved efficiency. We conquered the latency wall. We proved that the human brain is fantastically adaptable to mediated interaction.
But the price of that achievement is the erosion of our final, most personal boundary. The signals of fatigue and engagement, which were once subjective and internal and private, they have now become objective, quantifiable, real-time data points.
And that data can be fed into closed-loop systems, AI algorithms that can adapt training sessions, assess your productivity, maybe even determine resource allocation. The space behind your screen is no longer a private mental workspace.
It's a biological data terminal.
We achieved this massive silent restructuring of our working minds, and it enabled a new high level of digital efficiency. But the cost of that success is the loss of control over the boundary between our private internal state and the external digital observer. It's not about informational privacy anymore. It's not about protecting the words you type. It's about the privacy of your own fatigue, your own engagement, your own attention, which machines can now read better than you can hide. The price of digital efficiency is the permanent outsourcing of our internal state to the algorithm.